So the discussion today is going to be really about, they're calling it managing the IoT traffic jam, and I'm wondering if that's why we're getting into these low power, wide area networks and what everybody's going to really be talking about today. I'm not going to listen to Carl. I'm not going to introduce the panel. I'm going to let them introduce themselves, talk a little bit about themselves, the company that they're with, and how they actually play in this space. So let's start at the other end. Dave.
Thank you. So my name is Dave Schendel. I'm the CTO of a company called Senate. We are a network service provider in the LPWAN space. We're deploying LoRaWAN networks in the United States and have about 100,000 square miles worth of coverage today and are expanding rapidly.
Good morning. I'm Michelle Fitzhugh. I'm a Senior Business Development Manager for T-Mobile and responsible for growing the IoT business.
Hi, I'm Craig Miller. I'm with Sequence Communications. I run marketing and carrier relationships for the company. We are an LTE chip manufacturer, and our focus is on the Internet of Things, in particular the roadmap to address the opportunity in IoT.
Great. Good morning, everyone. I'm Doug Wilson with Verizon. I'm here representing the Verizon Partner Program for the Internet of Things. So if you don't know who we are, then shame on you, because we are the leading carrier in IoT solutions.
Hi, good morning. I'm Brian Dunn. I'm the Business Development Director for Semtech for LoRa Networks in North America. And our play in this space really is to support the LoRa Alliance and the standardization that will ultimately lead to the scalability that we all need to connect these billions of edge devices.
So Carl told me that he wanted to have a spontaneous and open discussion of the state of connectivity. And in doing so, it's great that we have some people that are on the technology side and spinning the silicon and some of the people that are actually deploying the services, because there's different things going on. Let's start in the middle. Talk about the entire ecosystem and where you guys are playing right now and how you view it if we take a look at it from a top down, right?
Yeah, I can give you a perspective. Us chip vendors, we're at the bottom of the food chain. So we see it all, all the way to the top. I think the carriers kind of represent the top of the food chain for us, and then their customers. We're necessarily kind of, I guess, 3GPP bigots. Okay, we believe in the scale and the global standard of the technology. It's ringing in my friend's pocket here, so it works, right? Now, the global standard, the cellular technology standards that have evolved from 2G to 3G to 4G have proven their value, and the investments made by the operators here to build, wide coverage, high availability, high reliability, secure networks, initially focused on mobile broadband, cell phones and iPhones and tablets, but that framework they've created and the standard that exists is really a perfect framework in which to serve the IoT market as well. And we see things happening in the technology standards to make LTE technology in particular more suitable for the applications that the IoT demands. So lower power, lower cost, better coverage, things like that are happening in standards. So we're driving that roadmap in our silicon and serving that to the module makers and device makers that then enable the Verizons and T-Mobiles of the world to deploy.
How about Brian on the other end?
Okay, so if we speak about silicon, which Semtech certainly does play in, so we provide the physical technology, the physical layer for the chipset. However, that play is really important because it's from the physical layer that when you start to go up the stack and start to service and solve problems, that physical layer enables, and the standardization on the MAC layer enables developers from around the world to best provide solutions as the market evolves. So Semtech feels very strongly about the standardization of LoRa and the fact that any developer can develop a private network or a public network solution, in the case of Senate, and actually start to connect a lot of devices.
So my dad used to say, if all you have is a hammer, everything starts looking like a nail, right? People started connecting things to different types of networks out there, 3GPP networks, that probably shouldn't have been. Some of them should be. But just from a longevity standpoint, I believe that 3GPP has done a fantastic job of giving us some really driving costs out and giving some really good solutions. But what about from a longevity standpoint? How do we make these solutions out there stick longer for these industrial type solutions? And I want to hear it from a service provider standpoint, because you guys are the ones that have to stick behind your customer. So, Doug?
Okay, sure. So good, interesting part when you talk about that, James, because I think it's that long term. And again, sitting next to Craig here and seeing the direction of where we're going with the solutions and become these, we're hearing a lot about the Cat 1 and the Cat M solutions that are coming out. I think that's where the long term is. We're looking at that global solution for IoT, and how do we do that? We've had so many disparate networks that have been out there today with the different carriers, and looking at really putting it on, if you look at LTE and the direction it's going and where Cat M is going, at Cat 1, the devices that are coming out, Sequans is really involved with that, that's the long-term, the longevity of it, is by having really truly global IoT solutions that will work on anybody's network, that will work anywhere. We'll keep those solutions going much longer. And the development tools that are taking place along the lines of carrier integration, like what we're doing with ThingSpace, and allowing anyone to really just develop a solution and say, come up with an idea, develop that solution, make it work on the network, will really open it up to that long-term evolution. Hey, I threw LTE in there. So, but really, that's what the bottom line is making sure that I think that from a carrier aspect of it, being able to support it, it's the long term of where LTE becoming a global network that all carriers are going to be able to work together, and all these IoT solutions are going to be able to work together.
Michelle, anything?
I mean, I think he said it well. It's really boils down to LTE at this point. You know, the focus needs to be on building products based on the LTE standards. That's where the longevity is.
I think what's interesting here, if you go back 5 years or before these two folks deployed LTE, one was a GSM carrier and one was a CDMA carrier, and that each had its own ecosystem, and it had required its own investments in network technology and device technology. They converged when LTE, was chosen by both of these, and really all the major operators worldwide. That became the de facto global cellular standard for broadband, and now for IoT as well. They can leverage that same ecosystem. So it's got longevity built in. They built a network that can scale from Category 6 at the high end, 300 megabits per second, down to Category M, which is going to be under a couple of hundred kilobits per second, and crosses that performance, price, power kind of continuum that the IoT market needs.
But maybe why not LTE? There are other guys doing other things. Let's hear that one.
Yeah, so I mean, I think the first answer to that is that you can start building those solutions today. So we believe completely that there's no one-size-fits-all technology solution to the IoT space. There is an absolute need for 3GPP-based solutions, LTE-based solutions. There's a need for local area solutions based on Wi-Fi and Bluetooth. But we also see this space in the market that Cat-M is going towards that can be addressed today using the technologies that are present in some of the LP-WAN technologies. Certainly, we also agree, I think collectively, those of us who are part of the LoRa Alliance, in the value of having an open alliance, an open architecture that is a group of companies collaborating on making standards that guarantee interoperability and ultimately lead to the longevity of those solutions. So I think the biggest difference there isn't necessarily that we don't both see the market space. There's an opportunity to take advantage of it today with existing technologies that may also ultimately kind of look similar in the Cat-M space.
A year ago, I went to CES, and I sat in a conference room with members of what were the LoRa Alliance, and there was about 4 people in there.
Yep.
Last summer I went to Paris, and there was about 250. Okay, I couldn't get in the room in Vegas this year for the LoRa Alliance meeting.
Right.
Is there a difference needed between public and private networks and people deploying their own private networks from a technology standpoint today?
So the answer is no. You can use the same fundamental technologies to deploy either public or private networks. So that's taken care of by the constructs within the standard and within the alliance itself. The alliance, just to get on that, has grown exponentially over the last year. It's I think the stats were it was the fastest growing alliance, technology alliance that's ever been founded. I think we're over 130 members at this point in time. Major tier one companies part of that. There isn't a requirement for different technologies. That needs to be folded in within the standards process and within the protocol itself, and it has been. There is certainly, as a public network provider, an argument to be made of the value of a public network over a private network. That argument doesn't always hold with everyone's opinion. Specifically, when we talk about concepts of data localization, where is the data allowed to exist? Where is it allowed to transport to? In the public networks, that necessarily flows across certainly, county, state, even international borders in some cases. And that, in many cases, what we see is the ultimate line that kind of demarcates where some of the private networks will want to go. It needs to stay in this building. That's a private network, typically.
So actually, I'll just mention that the LoRa Alliance we broke the 200 mark on our way to 300 members. And the most recent meeting was in excess of 600 people at the open members meeting. So the energy and the progress around the technology is absolutely real. I would also add that one of the great things about LoRa and the open protocol is that anybody in this room, anybody can become a low power WAN network operator tomorrow. You can purchase a gateway or hardware from our ecosystem partners, and you can connect to the cloud and start having long range edge connectivity. I would also, I think, like to mention concerning LTE. In my opinion, I think everybody should agree that LTE, low power, and unlicensed spectrum are going to coexist. Neither one of those are going away. There are public networks today deployed. We've got 12 countries deployed. So in reality, it's not one size fits all. And I think the conversation should be about how they coexist and not either or, because the reality is that they will. So the minute that the LTE engineers and maybe the unlicensed spectrum engineers agree that we're going to coexist and we're going to connect a lot of devices, I think that would better move the progress forward.
I would say this, look, we're, as a cellular, LTE technology provider, we're not fighting LoRa or the guys who aren't here, Sigfox and Ingenu and some of the other proprietary standards. I agree with the premise that, IoT, I think the last panel did a good job of talking about just how diverse, how many use cases, how many business cases, enterprise, consumer. It's so diverse. There's probably room, and it's sort of a different horses for different courses kind of decision that a particular enterprise or consumer has to make on what network technology makes the most sense for them based on their needs of performance, price, power, security, coverage, all of those things that are going to factor in. So there's room for all of us at the trough.
So how does coexistence look, right? Have you ever pulled up an FCC spectrum frequency allocation map? How's that going to happen? Doug, I saw you shrugging.
I think really what it comes down to is it's going to be the providers out there that are going to provide the gateways between these two networks. That's what it really, somebody's going to figure out who's going to do that, right? It hasn't been done yet. There isn't a gateway between LTE and LoRa, for example, and those need to be built. I mean, somebody has to have the ability to put something together that says, how can we put a gateway between, because they definitely fit. I mean, all the different networks fit. Even in the unlicensed spectrum, what kind of devices are going to be connected there? As long as you have someone out there, and I'm hoping somebody maybe in this room is thinking about this, of building those gateways to bring those networks together, I think they certainly can coexist. And you talked about the longevity, and we talk about, what the subject is, the IoT traffic jam. There's a perfect way of getting rid of the traffic jam by having these disparate networks working together. Not just from a carrier perspective, but from LoRa, from unlicensed spectrum. I think the gateways are the thing that we need to make happen.
They do actually exist today.
Cellular backhaul.
Cellular backhaul. There's a number of suppliers in the ecosystem who have this. We've got Multitech, I believe they're here today. They have a cellular gateway. We also have Wi-Fi gateways for backhauls. So the connectivity to different backhauls does exist today.
So I just want to add. Sorry, great.
And I was going to say that's great for the future where we're going. I guess what's happened is that we're not seeing them deployed as much. I mean, they're there and they're happening, but in the IoT applications I've been working with, and we're not seeing them used as much where somebody's saying, yeah, okay, I've got this device, and again, go back down to the DNA level of IoT. We're not seeing the devices where the gateways may be there, we're not seeing it at the device level quite yet.
So I think we do see a few of those devices coming up that are multi-communication devices. And the key element of the technology stack, to reference what the folks were saying in the last panel, that needs to be present is that IoT platform piece that's tying together disparate connectivity technologies to a solution. And that's really where I think that the connectivity kind of goes between the different underlying technologies is up at that layer. It's at the solution layer as opposed to kind of at the bits and bytes layers of the gateways and things like that. That's a mechanical problem that we can solve or have solved. What really is there is how do you provide a solution that takes intelligent advantage of the different kinds of connectivity that are available through the different technologies.
Well, I think you're seeing that with companies like Core and others in that space that are able to aggregate these different connectivity options and give a platform for the customer. The complexity, though, is in the device itself and what bands it's accessing. And that's where, do you want one SKU or 5?
Is that something that T-Mobile and Verizon are bringing on to their partner programs, are guys that actually can balance across connectivity? I think of guys like Core or Stream, right, that may have a platform and be that single pane of glass and single connectivity management layer.
Well, I think you saw yesterday, James, that both Core and Numerex, I mean, several of the different MVNOs out there are already working with all the carriers, T-Mobile, ourselves, and the other carriers out there to bring that all together. So I think from an aggregator standpoint, the MVNOs are already partnering up and realize that that's the space that they want to go to. Individually, as a carrier, when we look at some of the solutions that we specifically are providing to customers at Verizon, again, it comes back to the development, having the right development tools to be able to have the solution so somebody can easily bring something to market, and then working that through the aggregators, working it through the MVNOs, and letting them offer those solutions too.
Carl, are you out there? Are you roaming the place for
sleeping?
I would love to hear some questions from the audience.
You'd love to hear some questions from the audience? Do we have questions? Oh, look at that. Hold on one second.
Hi, I'm Gustavo from Ericsson. One question I have for the LoRa guys is that in LTE, we understand very well how security is implemented and authentication. And there is a huge infrastructure that was developed to achieve that. Do you see LoRa trying or striving for that kind of security and authentication?
So certainly the protocol and the constructs around it provide for security and privacy of all of the end devices. It's required for every single one of the end devices. I think it's a very important element. I had a question asked to me not too long ago, which is, in the unlicensed spectrum, sometimes that's looked at as kind of good enough technology, right? So if you want to guarantee you have delivery, you need to license that spectrum. We compete in the unlicensed space. So the question was, well, do you really need to provide security constructs on top of that as well, or is that another good enough compromise to make? And the answer, I think, is very categorical. No, you need to have security, you need to have message integrity, you need to have authenticity of all of those communications. It needs to be the foundation of that. And it is, in fact, part of the networks that the Alliance members are building right now everywhere that they build. So it's a critical element, yes.
So I want to kind of do the antithesis of that one, okay? Laura, there was this thing called WiMAX at one point, and everybody was nuts for it for a while. And then it tried to become a carrier solution, and it started adding to its BOM costs and going a little nuts. Are you guys trying to be a Wi-Fi-like play, or are you trying to be a cellular-like play?
So I would say neither. So if you look at low power wide area, this is a new market, and it's on one side you have cellular, which is high data rates, at least currently, maybe not as low battery consumption. On the low side, on the other side, you have Wi-Fi and local area networks. In the middle, I would say you have low power wide area networks, which again, they're low power, they're long range, and they're low cost. So, and it's I think the advent of these technologies that has opened up this market. We look at the low power WAN market to be the driver of connecting billions of devices that weren't addressable, 5 years ago. So I would say it's neither cellular nor local area. So they all need to coexist, and all three areas will connect devices.
Can I take a shot at answering the question from a different angle, potentially? So I think one of the things that characterizes the difference between those is the kind of SLAs and how the SLAs are provided on top of those networks, where Wi-Fi is very much, you get what you get, and then the carriers are providing very high levels of quality of service on top of that, and they have a very mature and robust infrastructure that's been built up over the years in order to provide that. What we have as an opportunity in a new market space like low-powered wired networks is a way to rethink and reimagine how those networks get deployed in order to maybe find a new set of compromises that sit somewhere in between. So fundamentally, the network architectures that many of us, not just in the LoRa community, are deploying are SDN-like architectures that leverage a very unintelligent gateway that is easy to deploy, easy to replace, and where network redundancy can be achieved by dropping additional cheap gateways in and still centrally managing those without any interruption to the end devices or the gateways or anything else. So it's a slightly different deployment architecture that still yields high levels of quality of service without the same kinds of network infrastructure that were built up in the past.
Maybe you could talk a little bit about a profile of a device type that's connected out there. How it's being used today, because you guys have a ton of endpoints deployed already.
Right.
One of the pioneers in this space, right?
We do. So certainly that's the other big kind of characteristic in the low power space is the devices themselves fit a certain niche in the IoT spectrum. We are not deploying, we do not support devices that are streaming video. We don't support devices that are moving megabytes worth of data back and forth between them. There's no reason that LPWAN networks can't support bidirectional communication, acknowledged communications, all those things we do. But we're talking about devices that are probably connecting several times, dozens of times a day, not on a continuous basis. And that flows through the entire architecture and is part of how you achieve ultra-low power devices. The association of the device with the network, in our case, is a one-time event in the device's life. So those extra packets that are sent in order to associate with the network aren't with the base station, they're with the controller. So that happens once, and then you're done. But it flows through that very low power and very low data rate application. A great example are things like water meters and tank monitoring solutions. Anything that is kind of monitoring supply chain points are great opportunities for that kind of a network.
We've got a question here.
Yeah, I'm Sri Ramachandran from Numerex. Question is, so if I'm a decision maker, say the chief IoT officer at a large global enterprise, and I want to kind of have a unified infrastructure where I'm going to be leveraging carrier connections in the US, maybe abroad. Is there a way that this unlicensed spectrum can play into my strategy? And how would that work? And how would the carrier relationships be affected globally by that?
So technically, that can absolutely work. It typically will require either integration on your part or through one of these IoT platforms like Stream or Numerex, somebody like that. The devices themselves, I won't talk about the 3GPP side of it. I'll let you guys talk about that. On the LPWAN side, you need to look for a solution that has a global footprint. So you can build a relationship. It's not an easy task necessarily, so it's not a one-size-fits-all, but you would build relationships with local carriers in the LPWAN space as well as the 3GP space, as well as international carriers, in order to provide devices that can roam across that. In the current ISM bands, the unlicensed spectrum that are being used, you can take the same device if it's created correctly. And that can work in North America, that can work in Europe, that can work in South America, that can work in Asia, all simultaneously, much like it can in the cellular domain.
We have another question.
Okay, hi there. My name's Brad Smith. I'm from Converge. It's a demand response company. And my question to you is specifically managing the IoT traffic jam. Our application is demand response, and one of the primary goals we have is to be able to reach from a top level down to all of our devices within, say, 2.5 minutes. And that could be like a statewide, very large deployment. Currently today we have issues where we've implemented some 3G cellular, and we'll drop, say, 500 devices in on an apartment complex, and trying to hit all 500 on a single cell tower overwhelms things. So my question is about density and how the different technologies could address a very quick, rapid response in a very dense situation.
Again, to me?
Seems like it.
I remember applications like him.
So I think, it all comes down specifically to the details of the application and what level of traffic is going to be deployed. The different LPWAN technologies, and my competitors aren't up here to kind of defend their side of it. They have different characteristics. Around the amount of downlink traffic that can be sent and around how you can reach devices in a very kind of cost and power efficient way. What is critical to being able to do that is a protocol, a MAC layer protocol that lays on top of it that allows the device to very power efficiently listen at specific periods of time. So you need a characteristic like that. Our networks support that kind of a reach, so a downlink message that's unrequested, and still enable you to be battery powered. So that's the key element there, and it can meet goals of devices that need to be reached, within several seconds or up to a couple of minutes on a unrequested downlink basis. You can, if you have power available, then it's a whole different story. You can be listening all the time. And then finally, when it comes down to the density question, that's another critical consideration as you look at how networks get deployed. And the cellular folks went through this as their networks evolved from looking from initially coverage-based models to capacity-based models. And LPWAN networks need to be able to follow the same trajectory. So initially, as we do our deploy-outs, it's coverage-based. As you drop in 500, 1,000, 10,000 devices into an area, that will then cause us to redeploy, add additional capacity into that environment. And it's critical as you look at the technologies there that you pick a technology that enables the network to resize itself as that were to occur. And that's something that we do. Our general rule of thumb is that when we hit around 50,000 devices underneath a base station, that's when we would add capacity to the network.
I would add, I guess from the LTE perspective, what's happening in standards, it kind of addresses this a little bit. 1st of all, it helps to understand, everybody in here has a phone. that phone is getting on the network every second, literally. Even if you're not using it, it's saying, I'm here, I'm here, I'm here. This kind of idle mode, presence attribute of a traditional mobile broadband network. That is evolving in 3GPP. There are new capabilities built into Release 13 to allow a device to say to the network, I'm on a battery, and I'm only going to wake up every hour, every day, every 2 weeks even. You can configure that at association time. So it is use case driven. You have to, as a device or a service provider, have to kind of know what the right parameters there are. If you leave it in the kind of mobile phone model, you'll always be able to reach that thing every second. Every second you can send it a message, or it'll check for available messages. If you tell it, I'm a water meter and I'm reporting usage twice a month, you can't necessarily wake it up and expect it to because it's going to sit on a battery and it has to last for 10 or 15 years, which, by the way, is another attribute. I want to challenge the assumption set probably in this room about what LPWA is. LPWA is an attribute. It's not a market. It's a technology attribute. LTE serves LPWA the same way LoRa serves LPWA. We just take it from a different technology base. And I can build you an LTE IoT endpoint that will run for 10 to 20 years on a battery, on a couple of AA batteries, just like they can. So don't automatically assume that these proprietary, LoRa, Sigfox, Ingenue types of networks are the only ones capable of LPWA.
But with the recent restrictions on, there's single antenna restrictions on LTE Cat 1 devices out there from Verizon, from AT&T on usage, how do they address that mass scale up, mass notification issue? Right? Have you looked at
I think that's more of a policy question, not a technology question.
Is it?
Yeah.
Okay.
Yeah. I mean, by definition, LTE Category 1, and then I'll pass the baton here. Category 1 was defined in Release 8 of 3GPP. It looks just like every LTE thing you have on your table today. It's just lower speed, lower bit rate. Okay. Lower maximum
let's
peak rate.
back up and look at that.
In other words, I'm sorry. It by definition is once a second.
The LTE chip looks like a school bus. The Cat 1 chip looks like a school bus with all its seats removed to reduce the power consumption and those things. And one of its tires, because it's only got one antenna, versus the multi-antenna that my handset has.
You're crippling me here, man.
Let's go back and talk about
What
it.
an analogy.
Right.
We've got questions back here.
I disagree with your analogy, but point being, it looks like LTE, slow-speed LTE is what it is for low cost and lower power.
Well, and I think if you're thinking about capacity, LTE, again, you've got more lanes on the freeway and lower latency, regardless of how many bits that application is sending. So LTE-capable devices will allow for a lot more drops.
Right.
One location.
Yeah.
Okay.
And you were talking about again, going back to what you're saying, James, it's about, AT&T, Verizon are putting these caps on it. Well, this is high bandwidth usage, video, but again, we're doing video streaming today, so that's not like it's a challenge. It's something that we're offering out there today. But what the Cat 1 and the Cat M devices do is to drop it down to where we don't need to have that kind of capacity. We're not concerned about those type of devices in the world of IoT.
Well, to me, it's not capacity. It's the one connection a day issue. Right?
That wasn't announced by T-Mobile, I don't think.
No, not by T-Mobile. You're safe.
Wait.
Again, it's a policy thing, not a technology
Okay,
thing.
wait. I'll go for policy, but just tell me, are we really doing half duplex? Because if we're doing half duplex, then it's an engineering thing and not a policy thing.
So in Category M, our expectation is, and maybe the carriers don't want to disclose their specific plans, but we expect the majority of Category M and narrowband IoT deployments to be half duplex. That's so you can get the lowest possible cost into the devices and the simplest, lowest complexity implementations.
Okay.
Hi, everybody. Chuck from Cisco. Let's say that everybody in this room is wildly successful, and by the end of the decade, the amount of network traffic associated with IoT devices is up by, say, 2 orders of magnitude. Nobody's networks are anywhere on a trajectory to manage that kind of explosive growth. So the question is, what do we do if we have a crisis in terms of our ability to haul bandwidth on any networks back from all these IoT devices? And some of the things I'm thinking about are like data compression or fog nodes on the edge to try to bash the higher bandwidth stuff down, better encoding on wireless networks, MIMO technologies that use lots and lots of antennas, try to convince the governments of the world to give us more spectrum. Good luck on that, but it's a possibility. We could carve things up into micro and pico and nano cells, or for traffic that can manage it, meaning devices that are anchored to concrete foundations, move the traffic back to wires and fibers. Which of those technologies are the most promising if we find ourselves in the enviable position of needing 200 times more bandwidth than we're using today by the end of the decade?
And I thought I was going to let you guys off easy with that one. Go ahead.
Michelle?
I think more spectrum.
Yeah.
I mean, that's my answer.
Spectrum management, I mean, it's management too. It's management of the data, right? So you got to have better tools to be able to manage the data. You obviously, at the edge, you're going to be able to manage it even at the device level and in the network. So you need management of that data in all three places to be able to, again, when you're taxing the networks, having the spectrum availability. I think, again, what we see in the promise of what Cat 1, Cat M brings to what LTE is providing out there is going to help reduce some of that data requirement for the network to tax the network. So even though everyone being wildly successful, and we all hope you are, certainly the networks are going to be able there to be supported through the spectrum that's coming out. We're seeing, we're going to 5G. That's the next evolution we're seeing. So we're going to get more capacity there. So certainly it's coming, and we've got to be ready for it. That's the most important part. So
I would say also the thing going on in standards is, today LTE networks are nominally, they're 20 megahertz systems. They're wideband systems. When you get to category M, you're down to 1.4 megahertz. When you use narrowband IoT, which is also part of Release 13, it's 200 kilohertz. So you're starting to slice up the available spectrum into much narrower bands or much narrower channels. You're utilizing that spectrum more effectively, considering these use cases, these IoT use cases that need a few hundred bytes per day or kilobytes per day or something. Those channel sizes make a lot more sense, and it does conserve RF resources accordingly. The other question, I don't know if I heard this in your question, was, or the other challenge I think both of these guys have is, if it's true that there's hundreds of millions of things on, not phones. They have 100 million phones on their network today. Now there's going to be 100 million or billion or whatever things on their network. How do you make sure your core network is scaling properly to support all of that, and that you're not having signaling storms that take down the mobile phone network to support the smart meter network or what have you? So there is going to be a traffic management problem in the core. And I know Verizon publicly disclosed they've already made the decision to deploy a separate core network for their IoT traffic versus their mobile traffic. So that's a step in the right direction. There's also work in standards to reduce signaling overhead, these long latency devices that, you don't have to wake up every second. That helps in terms of signaling capacity. So there's a lot going on in standards and in the way networks are architected and deployed to help solve that problem.
Cheers, Carl. So I did say I'd heckle you, Brian. I'm only joking. So I have a question really for Michelle and for Doug. So I work for Multitech. We make gateways, as Brian alluded to. They do have cellular backhaul in them. And a lot of the enterprises really love that. It gives them the ability to make that low-power wireless access connection today to the edge, to the thing, and then backhaul over cellular. But I've been to a number of these kind of events where we have panels about low-power wireless access, and we end up getting into this, licensed versus unlicensed, this technology versus that technology. I really honestly feel that there's far more power here and value when you combine this together. So how is Verizon and T-Mobile going to embrace that? Are you going to be monolithic around a licensed spectrum technology, GSMA, or are you really going to embrace this mashup of technology?
Well, from our perspective at Verizon, I believe it's more coming down to the application. I think that's what was kind of brought out earlier. What is the application of who's developing this IoT solution that's out there? Certainly, if they're going to embrace it at their end, the connectivity is connectivity. That's what it really comes down to. Oh, sorry. There we go. That's working. My network must be down. Here we go. So I think it really comes down to the application, the device that you're putting on there, the solution you're trying to, what your problem you're trying to solve with the IoT solution. When you look at overall, certainly we want to embrace anyone out there that wants to build a solution, whether it goes through a multi-tech gateway where it's LoRa on one side and LTE or any type of cellular on the other side. So I think that for overall, when we look at it, it really comes to where we start from, and that's the solution, the application, and it's embracing those together and then pulling the two networks together. It's not about Verizon making a decision of saying, we're going to not allow that, or it's just licensed spectrum. We're open to providing those, and that's, again, why we want to make it more of an open interface to be able to provide it. We're definitely the network provider for IoT solutions, and we want to continue to do that. Whether it's working with low power through one of your gateways, I think that's fantastic. I think that's a great way to go, depending on what the application, and it's all about the solution.
So, just to defend Doug's honor there, it's white space that failed, not your network.
I was just going to answer the question from T-Mobile's perspective. I think it's the same as Verizon in that we'll enable it, but we're not going to, the engineering team isn't going to build the gateways or support making that happen. I think we have to rely on our partners, such as Core and Numerex, to enable that for the solution. Yes.
Yeah, hi, this is Rajiv. I'm from the Tech Mahindra group, and I have a question here. It's just stupid or something like that. When we think of IoT, we say that we have to deploy the millions of devices and billions of devices, and we have to interact with all these devices with data flow and the data processing. We already have the mobile cellular phones with us, and these mobile devices are on LTE and the cellular Wi-Fi networks. So are we thinking of making these mobile devices like the cellular phones to be IoT enabled? Do we have any use cases there? Means the transactions we do on the cellular phone, means all the day long we are working on our cellular phones. We have so many things, right? So can we think of enabling these mobile devices or cellular phones to the IoT devices? Is just a question.
So in effect, you're thinking about gatewaying using the cellular phones.
Utilizing the cell phone as the gateway itself, or as the modem itself.
That's commonplace today, right? I think your average Fitbit is using your phone as a gateway. Your average iWatch, Apple Watch, is using your phone as a gateway. I don't think that that's easily scaled to, tens of millions or hundreds of millions of these things that you're all trying to invent and deploy and make money on. My guess is phone as gateway for enterprise. No, not in enterprise or industrial kinds of applications.
Yeah, there'd be power issues, right?
Yeah, there would be power consumption issues. Did I lose my phone? Did I leave it in the airport? Those kind of things. So,
great for consumers.
Yeah.
Great for consumers and solutions.
Hi, I'm Dave Bundy. I'm with High Tide Technologies. We do cloud SCADA, and we're getting into home pump monitoring, which is using already a hybrid with a low-power network and then a gateway type of application. But the thing that I haven't heard discussed is the problem with putting this many devices on the cellular networks is the number of associations and the stuff that has to be done on the back end to support that many connections. Because, if I remember right, some of these outages that have been public lately in the networks was not the network outage, but what the association servers that were handing out permission connections. And so with like a LoRa situation, it's only one association for the gateway, and then the network handles all the other stuff. So how does that fit into the IoT expansion to millions and billions of spaces? Because I don't know how are the carriers going to deal with that many associations. Right now, every device has a phone number, but what it'll be down the road.
Well, I would say, from the standpoint, I understand what you're saying. I think the bottom line to all of this is we're building the networks. We understand the challenges that are out there for IoT. We're looking at those type of associations you're talking about. The network infrastructure has to be built to support that. We're working on building those in the back end. Again, going back to what Craig is talking about earlier about what we're doing with, I think that direction and looking at what Cat 1 and Cat M does for us is helping to reduce that part of it from a network standpoint. But overall, when you look at the number of devices, certainly we have to be there supported. I mean, the one big thing I haven't heard a lot of people talking about is, IPv6. Well, it's coming, and we all know it's coming. So these devices that are using IPv4 addresses today, they better be ready for IPv6 that's coming rapidly. So it's not just about what's happening on the cellular side, it's about what's happening overall and making sure that the network is there to support it. And we certainly, from an engineering standpoint, our network teams are always looking at it. We're talking to them all the time about what's happening in the world of IoT. So they're on top of it. I can't tell you specifics of what's going to happen, but again, we're looking at all of those things going forward.
And I think also Release 13, and all of the 3GPP, what they call machine-type communications, I'll call it roadmap. It's their effort to add features and capabilities that are IoT specific. That's one of the things that they've done is they've said, look, we don't want a water meter to register every day on the network. Just register once and forget it. And that's built into this protocol now, so that it does reduce the signaling and the amount of communications and the amount of wasted data and transmissions that go on. That does two things. One, it allows scale without bringing these networks to the knees, and two, it reduces the cost and complexity of the devices and of managing them. So that's happening in standards as well.
So earlier today on the panel, we talked about three very big challenges. One is time to market, one's interoperability, one's security. Okay, 3GPP, 3GPP2 are pushing those things through in a very methodical pace. The LoRa Alliance is addressing them a different way, but also in a very methodical pace. My question's around timeline. When are we going to get to Cat M? Are guys going to jump over Cat 0 and go to Cat M? What about narrowband IoT? And what's the actual timeline look like for devices in those spaces? And is it just a foot race right now in a land grab situation?
I'll give my perspective. It's, admittedly 3GPP biased a little bit because that's what I sell. But the Release 13, so Category 1 is shipping and deploying. It's certified, it's deployed, it's in devices, it's already out. That Category 1 was defined in Release 8 back in 2008 or 9. So that's a done deal. It's already happening. The next sort of step would have been what they call Release 12 Category 0. The problem with Release 12 Category 0 is it took an antenna away from LTE without doing anything to compensate for that loss, the link budget. So Category 0 is going to kind of be skipped in general. There may be one or two deployments, but largely it's not a phenomenon. So the next real meaningful step in 3GPP is what's called Release 13. And in Release 13, there are two, I call them both narrowband implementations. One's Category M, and I believe 3GPP is going to call it M1, Category M1, to just make it even worse. So M1 is 1.4 megahertz system bandwidth, RF and baseband. So it's lower cost, lower complexity, narrower channels. And then narrowband IoT is going to be called, guess, M2. Okay? So we believe that's the nomenclature that 3GPP is driving. So M1 and M2 are both sort of different implementations of a narrowband, but still essentially an LTE system. And they'll be interoperable, compatible with the existing LTE spectrum and frequency management plans that are out there. And the M2 or a narrowband IoT uses a 200 kilohertz channel, which sort of gives options to carriers in terms of how they want to deploy and where they want to put that spectrum or that traffic. So 2 different implementations, slight level of difference in complexity and performance. It's a couple hundred kilobits per second versus a few tens of kilobits per second. Similar cost structure. That's timing-wise. The spec freezes this quarter. So you'll see implementers, chips, base stations, RAN vendors, network vendors, working on trials and technology development and IoT this year. My best guess is the first deployers in terms of operators is 2017 for Cat-M. That's my best guess.
So with 5 minutes left, I'm going to go down the line. What wasn't asked that you would have expected today? And what do you want the audience to come away with from your panel session today? Start at this end.
Well, again, I kind of alluded to it early on, but I would really like everybody to come away with the fact that LTE, low power, call it, and a LoRa type of technology will coexist. And the sooner we get together on these technologies or how we can aggregate collectively, the faster that we'll deploy.
From my perspective, we didn't talk a lot about tools to be able to manage, again, the traffic jam that's out there today. We heard from some of the providers like yesterday in the battle platforms with Numerex and Core and some of the tools. Again, the carriers have the tools too, so keep that in mind as you look at it. We have our own tools. We just introduced things like ThingSpace, which is new to Verizon, but it's a tool to allow the developers to develop tools to work in our network. So, their tools are being built to manage that traffic jam. So that's the important part. We do have private network as along with our public network solutions. So again, those are the kind of things I thought we would come out of it, is what are we doing from a device perspective to manage the traffic jam. And that's, again, from a carrier perspective, we are developing many different tools at Verizon to be able to manage those IoT solutions that are out there and continue to manage the ones going forward with the solution we're providing.
I think I'm still working, right? I would have expected, I guess, maybe to get more questions about costs, right? Both device costs and access costs. How is that stuff evolving to enable this market to grow and to enable the business cases that you all have? I would have expected to hear more along those lines. And from a device side, I guess conceptually you can think of Category 1 as sort of 3G-like, and Category M or Release 13 as sort of 2G-like in terms of enabling those kinds of price points for the modules and that kind of thing. I would be interested really to know, if I was sitting out there, to ask these two what they're doing about the cost of access in IoT. And for that matter, I'm sorry, for the LoRa deployers, how much that's happening too.
So I think Doug stole my thunder on the tool piece. But yeah, if you're talking about traffic jam, you want to be able to provision hundreds of thousands of units very, very easily. And in order to do that, you need software tools and partners to support those types of transactions.
So with a new technology like the one that we're deploying, I would have expected questions about the maturity of the technology and when is it ready and when can they deploy against it. And the answer to there real quickly is that it's very mature. So even though the alliance is relatively young, you can build devices today, you can deploy against live networks today in the US, in Europe, in Asia, ready to go.
Carl?
I'm here. I think we're good, right?
One for you.
We got left.
1 minute.
1 minute. So my only question for the carriers is, what verticals are going to be the first to take advantage of your Cat 1 solutions? Is there a particular marketplace that's like sweet right now?
Transportation.
Yeah, fly here, pay here.
Yep. Transportation, buy here, pay here, all fits in.
Vehicle asset tracking.
Anything vehicle related, because there's more of those than anything else.
Also security, I think, home and business security systems.
So just since I'm a carrier too, even though a small one. So we think that there's some interesting areas that aren't necessarily under great cell coverage that have some opportunities as well. So specifically agriculture that was mentioned in the earlier panel, we think that's very important. And the final one that again was mentioned in the earlier panel is there's thousands and thousands of companies out there that are building interesting things, and we really don't know which one of those are going to be the ones that are important. We have to be ready to catch those as they come down.
Well, great. I want to thank the panel. They'll be around to answer questions. Catch them in the hallway. Thanks, guys.
Thank you.